As Donald Knuck once said, that algorithm must be seen to be believed. Today, here are Group K, Joshua Esperanza, Jo Marie Osasha, Rafael Tijada, and Laika Marie Tingzon to show to you how multi-level feedback queue works. Multi-level feedback queue is to analyze the behavior or the time of execution of processes and according to which it changes its priority. The idea is to separate processes with different CPU burst characteristics. If a process uses too much CPU burst time, it will be moved to a lower priority queue. This scheduling algorithm is flexible and allows processes to move into different queues to prevent starvation.
Now, I would like to present to you the primary objective of this program. As mentioned in the background, the main objective of this program is to provide an accurate simulator for the algorithm that is considered as the hardest and most complicated among all existing algorithms, multi-level feedback scheduling queue. This program also aims to help faculty members teaching operating system or any related subject for their instructional material, and to help IT students taking operating systems or any related subject that wants to try simulating multi-level feedback scheduling queue inputs. Now let's move on to the specific objectives of this program. To create a multi-level feedback queue simulator using C language to attain all the objectives. To assign different colors in each process in the table and Gantt chart so that the users can easily identify the process and its values. To provide a program with good and neat layout. To validate user inputs according to the given range of values. To get the completion time in each process. To get the turnaround time in each process.
To get the turnaround time in each processes, to compute for the average turnaround time, to get the wait time in each processes, to compute for the average wait time, to display the Gantt chart based on user-defined inputs, to run the multi-level feedback scheduling queues using the quantum flow, round robin, and first come first serve.
For the scope and delimitation, this program only focuses on multi-level feedback queue. It is considered as the most complicated scheduling algorithm. The programmer still chooses this algorithm for them to help the faculty members for their instructional materials, especially when their subject is related to operating systems, and for students, for them to be able to simulate their multi-level feedback queue scheduling algorithms. And in order for the programmers to achieve all of the objectives, they're going to use C language as their primary language, and they will be using code blocks as their IDE. Because of this IDE and language, they will be able to come up with the most accurate and credible multi-level feedback queue scheduling algorithm program. And the programmers will be doing and changing the layout of all of the designs. For example, for the Gantt chart, they will be changing the colors of the processes for the users to easily identify its values from the table, for them to understand how it actually works. This program is only limited to certain minimum and maximum amounts. For our processes, we will be only allowing number 1 as the minimum amount and 10 as the maximum amount. While our arrival time, quantum time, and burst time doesn't have any limitations, because the program can still work even if you will input any desired amounts that you want. But they will still have the minimum amount. For the arrival time, we will be having 0 as the minimum amount, and the burst time, we will be having 1 as the minimum amount, and for the quantum time, 3 will be the minimum amount that you can enter. This program will also display message box if you fail to meet all the values that you'll be needing for this program. That's why you need to follow the minimum and maximum amount of the values that you will be needing in order for you to get the answer for your multi-level feedback queue scheduling algorithms, the different data sets that you want to enter. And for the quantum flow, for the first queue, we will be using round robin. For the second queue, round robin again. And for the last queue, will be the first come, first serve algorithm.
Now, we will show you our own program of multi-level feedback queue algorithm. Now, this is our program, which is the multi-level feedback queue scheduling algorithm. And the user will need to input the following. First is the number of processes, which is 1 to 10 processes. The program limited to minimum of 1 process up to 10 processes. So, if the user types 0 process, the program will show the number of processes must be 1 to 10. And the user will need to input again. So let's say 9. And then the user will need to type the quantum time of Q1. The quantum time has minimum of 3. So the user can input numbers lesser than 3. So if the user types 2, quantum time must be 3 or above. So 1 there. So let's say 30. The quantum time of Q2 there. So say 35. And then the user will need to type the burst time of the processes. First is process 1, 79, and arrival time of 75. The burst time must be minimum of 1. The arrival time must be minimum of 0. So let's say the user type 0 in burst 1. The burst time must be greater than 0. So there. The user will need to type numbers greater than 0. So 1 above. So 2 is 200. Arrival time 200. Burst time process 3 155, 150, 125, 500, 150, 800, 20, 20. Process 7 burst time 35 and arrival time of 300. Process 8 say burst time of 100 and arrival time of 750. Burst time of process 9 will be 35 and then arrival time of 100. There. So after the completion of typing up the needed infos, the program will show the process of computing the multi-level feedback queue. As you can see, it shows the timeline of the process. So here it showed at time 0, there's no process that arrives. And the first one that will arrive is process 6, which has the arrival time of 20. Here is showing the Gantt chart. Process 6 shows arrive at time 20. And since it's the first one that arrived in the Q1, the process 6 is processed. And since it has a burst time of 20, the process ended at time 40. And since Q1 has algorithm of round robin and its time quantum is 30 ms, it didn't go into Q2 and it ended or completed its process at time 40. So completion time 40. And since the next one that will arrive is at time 75, which is the process 1, the CPU is idle at time 40 up to 75. In multi-level feedback queue, the process will go in first into Q1 and then if it has remaining time, it will go into Q2 and if it has another remaining time again, it will go into Q3. Processes in Q1 is prioritized first and will be done first before the processes in Q2 and Q3. So as you can see here, P1 is done 75 since there's no process left in the queue and P1 is the first one in the Q1. It is done first, so 75 up to 105 since it has time quantum of 30. After that, the process 1 will have a remaining time since it has burst time of 79 and it has only 30, so it still have 49. P9 already arrived at time 100. Since P1 ended at time 105, P9 is done first before the P1 in Q2. Since Q1, processes in Q1, as I said before, is done before Q2 and Q3. It has a higher priority and will be done first. So the CPU process P9 first before the P1 at the Q2. As you can see here, at time 135, P9 is done and will go into Q2. And since there's no process in Q1 that arrived, P1
in Q2 is done because it is the process at the first line of the queue in Q2. And as you can see here, P3 arrive at time 150 and P1 arrive at time 170. And because the multi-level feedback queue has non-preemptive algorithm in its vertical algorithm. So processes that is done in the CPU will process until its completion of the algorithm. So it has time quantum of 35 the Q2. So it done 35 job time. So 135 plus 35 is 170. So it ended at 170 and go into Q3 since it has remaining time. Even though P3 arrived at time 150 in Q1, P3 is processed at time 170. It waited process 1 before being processed. And as you can see, P9 goes into Q2 after being processed in Q1. And since it has remaining time, it goes into Q2. But since P3 arrived at time 150, P3 is done first before P9 in the Q2. And then, same will happen in the next processes that will arrive. The Q1 will be prioritized first, and if there's no process left in Q1, at that time, the process in Q2 will be checked, and if there's no process in Q2, the process in Q3 will be checked, and if it has process, it will be done. So here, P1 goes down at time 170 in Q3, and it is done in time 340 because Q2 and Q1 has process left and is prioritized because it has higher priority. Here, P4 is done in Q1 and P4 is done in Q2 since there's no process that arrives on time 609. There's no process left in Q1, so Q2 is checked and P4 is there. So at time 654, there's no process in Q1, there's no process in Q2, and Q3 will be checked and P4 is there, so it is the one that will be done. There, 704 and 704 is the completion time of P4. It is the same at the other processes. So the completion time is computed when the remaining time of the process is 0. Completion time of P1 is 354 as you can see here at the Gantt chart, so 579. The P2 as you can see here in the Gantt chart, and so on and so forth. So turnaround time is computed with the completion time minus arrival time. And waiting time is computed with the turnaround time minus completion time. So here 354 minus 75 is 279, and 279 minus 79, so process 1 waiting time is 200 and turnaround time of process 1 is 279. Same goes into P2, which is 579 minus 200 is 379, and 379 minus 200 is 179. And same goes with all other processes. Average turnaround time is computed with total turnaround time divided by the number of processes. So 212.89, and the average waiting time is the total of waiting time divided by the number of processes. So 90.78. That's all.